guys, I hope everybody is having a great week 5. I can't believe this is our 5th week doing remote learning. I feel like we haven't been home that long, but I guess we have been. Um, I'm looking to break out just as much as you are after your Flipgrid videos. The general theme was just to like get outside and see people that did not reside in your home. So I feel the same way as you guys do. So today your goals are to kind of organize this unit, your notes and everything, because we do start the summative tomorrow, okay? So I want you to make sure that you take a look at the completed note section, make sure all your notes are correct that you have, and then you have now your sound and light formative, so you can go over these sound and light formatives. Make sure that you have the correct answers, okay? So I'll start with the sound formative, so make sure you have that in front of you, okay? So sound formative, what does a wave transfer? Waves transfer energy, okay? So remember, the energy is the ability to do work, so any movement or work that you see, that waves do transfer energy. What kind of waves involve the compression of particles? So remember, there's a wave that involves compressions and refractions, and that means the particles come together when they're compressed, and then when they're spread apart, it's called refractions. Those are longitudinal waves, so they kind of go like this, and they travel parallel to the disturbance, okay? And then 3 kind of goes right along with number 2, so which term best describes the particles in zones N and M? N and M, you do not see a whole lot of particles there. There's a lot more space. So those are our refractions, okay? And then in the PhET simulation, you worked on what happened to the wavelength when you increase the frequency. So when you increase the frequency, remember the wavelength decreases. And that's because you have more, if you're increasing the wavelength, that means there's more, if you're increasing the frequency, there's more waves in a given amount of time. You're not changing that given amount of time. So if there's more waves, the space between the waves has to be smaller, so the wavelength does decrease. Okay. Mr. Chapu was in a rock band that plays on the weekends. He and his bandmates decided to go purchase an amplifier. An amplifier will increase the amplitude of the sound waves produced by the electric guitar. Why would this be a good purchase? So it would be a good purchase because if an amplifier increases the amplitude, that means his band will sound louder. And if you're at a rock concert, you want to be loud, okay? You want that guitar, the electric guitar, to be loud. In the PhET simulation, when you increase frequency, what happened to the amplitude? So you should have seen when you increase frequency, something else did increase as well, but that was pitch, okay? So when you increase frequency, pitch is also increased, but the amplitude actually stays the same, okay? They are separate from one another. In sound waves, frequency is to pitch, like I just mentioned, while amplitude is to volume, okay? So if you increase frequency, you're going to increase pitch. If you decrease frequency, you're going to decrease pitch. The same thing with amplitude and volume, okay? Then question 8 was about the Doppler effect. So an ambulance has its siren on. What direction is the ambulance moving relative to you if the siren is decreasing in pitch? So if it's decreasing in pitch, that means the wavelength is decreasing. The wavelength is increasing and the frequency is increasing, okay? So that means those waves are getting further and further apart if it's decreasing in pitch. And when they're further and further apart, that means the ambulance is moving away from you, okay? And that all goes back to the Doppler effect, okay? So now let's take a look at the light formative, okay? So what wave property determines the color of visible light? That is wavelength specifically. So depending on what the wavelength is, that will tell you what color of the rainbow that color is supposed to be. Which statement best explains why we see a banana as yellow? So remember, a banana is yellow if it reflects yellow. Okay, so yellow is bouncing back at you. All the other colors are absorbed. Okay, this was a big one. A lot of people put absorbed yellow light. Use the graph of visible wavelengths produced. What color has the most energy? So the most energy, remember, has the highest frequency. So the highest frequency is violet, okay? And then using the diagram, this was probably the toughest question. So using the diagram, how would the beam of light change if the value of x for the light wave was decreased? So if we look at x, x is our wavelength. So if we decrease x, that means we're changing the wavelength. So the light would change color. So we would find a different color light. And then the last question, how are light waves different than sound waves? So I'm going to go through all these because I had a couple questions about this question. So all waves transfer energy. It's not just light, okay? So it can't be A. C says only light waves have amplitude, and D is only light waves have frequency. Well, I just went over the sound formative, and you guys saw that we talked about both amplitude and frequency about those. You did the PhET simulation manipulating amplitude and frequency for sound waves. So it's not just light that has them, it's sound and light waves that have both amplitude and frequency. But if we look, light waves are transverse, where sound waves are longitudinal. So remember, light waves are transverse. They can travel through a vacuum, and that's why we get the sun emits light, and that's why we can see it here, because space is a vacuum. So light waves can travel through a vacuum. Sound waves, however, cannot travel through a vacuum. They're longitudinal, so they do need a medium to travel through, okay? That's the big difference between light waves and sound waves, okay? I hope everything is going well for you, guys, and if you have any questions today, I do have an extra help Zoom call at 12:30, so just click on the link that I sent you this morning, okay? Have a great day.